In this video, we'll cover percentile ranks for simple and grouped frequency distributions. A percentile rank is defined as the percentage of cases in a distribution that falls at or below that score. In the previous video, we discussed simple frequency distributions. Calculating percentile ranks for simple frequency distributions is very straightforward. In the last video, we created a cumulative percentage column. The percentile rank for a score in a simple frequency distribution is simply the cumulative percent for that score. So, for example, the cumulative percent for 6 sexual partners in the last 12 months is 93.44%. This is also the percentile rank. 93.44% of respondents indicated a score of 6 or fewer. Here is a grouped frequency distribution. This is based on the same data as the previous example, and I've gone ahead and calculated cumulative frequencies, percentages, and cumulative percentage, which again was covered in the previous video. Calculating percentile rank for grouped frequency distributions is a bit more difficult because we don't have the frequencies associated with a particular score, only the frequencies associated with a range of scores. Here's the formula for percentile rank for grouped frequency distributions. Percentile rank is equal to the cumulative percentage below the lower limit of the critical interval plus the raw score minus the lower limit of that interval divided by the size of the interval times the percentage in that interval. In order to calculate a percentile rank for a given score, we will need to know L, the lower limit of the critical interval, and I, the class interval size. Here is the class interval size formula. It is simply the upper limit of the critical interval minus the lower limit of the critical interval. If we take the 6 to 8 partners category, the upper limit, as the book explains, is not 8. It is the point halfway between 8 and the first score in the next interval. So the upper limit is halfway between 8 and 9. In other words, 8.5. Similarly, the lower limit is the point halfway between 6 and the top of the interval below it, or 5, or 5.5. The upper limit for the 3 to 5 category is halfway between 5 and 6, and the lower limit is halfway between 2 and 3, or 2.5. You'll notice that the upper limit of one group is equal to the lower limit of the adjacent group. For the 0 to 2 group, or interval, the upper limit is the point halfway between 2, and 3, or 2.5. Again, same as the lower limit of the interval above it. The lower limit of the 9 to 11 group is halfway between 8 and 9, and just as the upper limit of the group below it is 8.5. As your book discusses, finding the uppermost limit and the lowermost limit is a bit trickier because there is no adjacent interval to compare it to. In this case, for the lower limit of the 0 to 2 interval, we will use 0, as one cannot have fewer than 0 sexual partners. For the sake of this exercise, we will also assume that no one in our sample had more than 11 partners, and so 11 partners is the upper limit. Now that we have the upper and lower limits, we can calculate the interval sizes by taking the difference between them. I'm going to have Excel calculate this for me, and so I'll start with an equal sign. Select the upper limit of the interval minus the lower limit of the interval. I can then click the lower right-hand corner and drag that formula down to the remaining 3 cells. Another characteristic of grouped frequency distributions is the midpoint, which, as you might imagine, is the point in the exact center of an interval. This is calculated by adding the lowest and highest score value and dividing by 2. We do not need M, or the midpoint, in order to calculate percentile rank, but M will become important in the next chapter on measures of central tendency. Now, let's suppose I would like to understand the percentile rank of someone with 8 sexual partners. The percentile rank of 8. The 6 to 8 interval is the critical interval in that it contains the score of 8. I'm going to go ahead and highlight this row just to make it easier to keep track of. Now, the first thing we need is the cumulative percentage below the critical interval. Here's the cumulative percentage column. 91.8% is the cumulative percentage below the interval of interest. X is the score we are interested in this case 8. L is the lower limit of the critical interval, which is 5.5. I, the size of the interval, is 3, and the percent within the critical interval is 4.918. We have to put all of those numbers together into the equation and have Excel calculate the percentile rank for us. This can be somewhat tricky because we have to tell Excel what order to do all of these different mathematical operations. If I were calculating percentile rank by hand on paper, I would first subtract L from X. Then I would take that answer and divide by I, then multiply that answer, everything in the parentheses, by the percentage, and then finally add that to the cumulative percentage below. The way to tell Excel what order to do math is to use parentheses. Excel will always do what is in parentheses first. Percentile rank is equal to the cumulative percent below the critical interval plus a very large term. And so I'm going to create a set of parentheses, and I will put that second term within those parentheses. So this whole part of the equation will go in the parentheses. Now, the first thing I want it to do is subtract the lower limit from our score. So I'm actually going to make another set of parentheses within the first set, and within this inner set I'll put X, in this case 8, the score we're interested in, and subtract L of the critical interval, the lower limit. Next, I want to divide that difference by the interval size, in this case 3. Then I want to take this whole term and multiply it by the percent within the critical interval. Now, this isn't absolutely necessary, but I'm going to go ahead and add yet another set of parentheses. And then say I want to multiply all of that by the percent in the critical interval. And I get an answer of 95.9%, which means that a score of 8 is as high or higher than 95.9% of the sample. Or in other words, 95.9% of the sample score an 8 or lower. If I double click on this equation again, you'll notice two things. One, the important terms from the table that I used have boxes around them, so I can check to make sure I used the right variables and the right scores. And two, the parentheses are matched in color, so we can find which set of left parentheses go with which set of right parentheses. So these purple parentheses represent the difference, which is the first thing we want Excel to do, and therefore is the most inner set of parentheses. The next set of parentheses are red, and are that difference divided by the interval size. And then the final set of parentheses, the black parentheses, are this term multiplied by D3, or the percentage within the interval. Everything within the black set of parentheses corresponds to this entire second term. Now, I appreciate that this is a very large and unwieldy equation. Thankfully, many of the equations we use in the future will be a bit more manageable. Not necessarily smaller, but in more reasonable chunks. If you're not comfortable writing this large equation, you can always add more columns to your table. So, for example, you could add an x column and an x minus L column and an x minus L divided by I column, and so on. And you could put those parts of the equation in separate columns. So for example, in this question, we're interested in an x value of 8. In the next column, x minus L, we can put an equal sign and select our x minus our L. Then, in the next column where we divide by the interval size, we could put inter and take what's in the previous column and divide it by the interval size. That gives us the term in the parentheses here. Next, you multiply by a percentage, and we could create a separate column for that as well. And you can label it however you'd like. Equals the previous term times the percentage in the critical interval. Now we have the whole second term. And we've gotten there by steps using multiple columns. And so now, to calculate the percentile rank, we simply type equals the cumulative percentage below the critical interval plus that second term, which we've calculated separately. And you see, we end up with the same result. These are two different ways to enter this calculation into Excel. Generally, I recommend adding columns. In the case that you make a mistake, it's often a bit easier to find the mistake if you've listed out every possible step. Let's try another example. Let's calculate a percentile rank of one partner. And we'll use the multiple column method. So in this case, we're interested in an x or a score of 1. X minus L, the lower limit, is equal to 1, our score, minus 0, our lower limit for our critical interval. Then we divide by the interval size. So we type equals the previous expression divided by H5, the cell that contains the interval size. Finally, we multiply that term by the percent in that class. Now, to find the percentile rank, it is equal to the cumulative percent below the critical interval. And in this case, our score is in the very first interval. There are no intervals below it. And so the cumulative percent below it is 0. Plus our second term. This means that someone with one partner has as many or more partners than 34.1% of the sample, or 34.1% of the sample has one or fewer partners. One way to check whether your answers make sense is to look at the cumulative percentage column. For example, 85.25% of the sample has between 0 and 2 partners. 34.1% is less than this cumulative percentage, which makes sense. For our first question, we were interested in the percentile rank of a score of 8. We came up with an answer of 95.9%. And you will notice that is slightly below the cumulative percentage for the interval as a whole, but higher than the cumulative percentage for the 3 to 5 interval. A percentile rank should always fall between the cumulative percentage of the critical interval and the cumulative percentage of the interval below it.